Hi all, welcome to today's session of image compression. So in this session we will be just dealing with how to do the image compression in MATLAB. So hope you all have an account in MATLAB and just sign in to your account to do the image compression using SVD. So first we'll just clear all the open commands windows and the saved images before. For that we have the code CLC clear close all. Using this, the above all previous data which is stored are cleared, and now we'll just move on to image compression. There you have A is equal to imread cameraman.tif. Okay, the thing is the cameraman.tif is a already built-in grayscale image in MATLAB, and by imread we ask the MATLAB to read the image file, and we just label that as E. So A is the image which the image is already built in MATLAB, so the we ask the MATLAB to read it as A. And now by A equal to double A, so by that what we mean is by default images are stored as units. Okay, and now SVD requires numerical calculation, so this double, the chord double, it in fact converts image to floating point numbers. Okay, so that it helps the MATLAB to read it. Okay, now the chord for displaying the original image, so for that we have figure show the image. Okay, then the title original image. So what this chord helps us to, will have the original image, the built-in grayscale image will be displayed with the title original image. Now we just go for the SVD. For that we have USV, just we have this command, and using this command we are going to perform SVD compression. Okay, and now you know this U is left singular vectors and S is the diagonal matrix of singular values and V is the right singular values, as we did in all the problems. Now we'll have to choose the number of singular values for the compression. Okay, so we choose K is equal to 30. K actually in fact it is the number of largest singular values which we need to consider, and if we apply smaller K values, then what happens is we'll get the more compression and we'll get a low quality image, and if the value of K is larger, what happens is less compression will be applied and better quality will be given. Okay, now in the next step we have AK is equal to, we have this command, and for this what we really do is, here we have the first one U colon 1 colon K, right, which means the first K columns of U is considered, and this is the first K singular values. Okay, by this we mean the first K singular values, and by this we mean transpose of first. We have the dash here, which means we'll have to take the transpose of V and we consider the first K columns of V. Okay, we just multiply them, and which gives you AK. Our AK was given by UK SK into VK transpose, as we did in the problem. So this is the way we'll this is the way to get the compressed image. Now we need to apply the code to display the compressed image. For that we have figure show the image under the title compressed image with the K equal to, will be given with the K value. Okay, and now we can also adjust the compression ratio, and for that we have the chord original size is equal to, just give the chord, and compressed size is equal to, we need in the compressed size we need the, like we need the first K columns of U and also the first K eigenvalues and the first corresponding the first K columns of the V transpose. Okay, and just give the chord and just type display the we'll also display the compression ratio. Okay, and now by entering the chord you can see this is your compressed image. Okay, this was your original image by default, which was stored in the MATLAB, and this is your compressed image when K is equal to 30. Okay, now let's see what happens if K was equal to 30. When it is 30, we have this compressed image. Let's see what happens when K is more larger. Okay, let's see have the value of K to be equal to, maybe we'll just give it is 50. Let's see what happens. Okay, when k is equal to 50, let's see what happens. And your compressed image is this. See, now this is more like it's having a more quality, right? So whenever you increase your k values, like the first k large, like the first k eigenvalues are used, and then you have a more quality image. Okay, if you are increasing this k to be equal to maybe say 100, then you will be having more and more, what to say, more and more quality image. Okay, so that's how you do the image compression in MATLAB. Hope you got it, and you can practice this in your account from MATLAB. Okay, so with this we'll be concluding this module. Thank you.